Hello, so this is Clemens Semler speaking. I'm a board member of the Java Code Forum, and it's a pleasure to me to welcome you, all of you, to the second of our 2023 webinars. The topic for today is secure hardware for digital currencies. In today's rapidly evolving digital landscape, ensuring the security of digital currencies has become an imperative for stakeholders in the high-tech sector. The escalating threat of cyber breaches underscores the critical need for a hardware-based security framework, fortifying transactions, shielding sensitive information, and bolstering trust in the burgeoning realm of cryptocurrency. Our presenter today is Timo Lisk, also board member of Java Code Forum. Timo Lisk is a lead principal engineer in Infineon's digital security and identity group. He started working as a smart card software engineer in 2003 and has been using Java card technology ever since. At Infineon, he leads a team of system architects who help customers integrate hardware-based security into their designs by providing security solutions for payments, identity, IoT, consumer electronics, and automotive. As a member of the Java Code Forum Business Committee, he is also involved in the standardization of Java card technology. So if you have any questions during this webinar, please add them to the chat. We will then collect all the questions and raise it in the Q&A session after the presentation. Or you can directly ask them in the session after the presentation. The presentation will be sent out to all of you after the webinar, as well as a recording of the webinar to watch again or pass on to your colleagues. So with this, I would like to hand over to you, Timo. Thank you.
Thank you, Clemens, for your introduction. And also from my side, hello to everyone on our webinar call today. And the reason why I choose to discuss this topic today, secure hardware for digital currencies, is that I find the use of digital currencies to be truly exciting. And since Java card technology can help to make digital currencies even more secure to use, it has become a popular choice among hardware wallet manufacturers to keep digital assets safe from potential threats. So I'm happy to share with you today why digital currencies and Java card technology are really a good match, and how secure hardware can help safeguard your digital wallet. And if you already paid attention to this first slide, you maybe have remarked that I changed a little bit the title. I replaced the word secure in the title with secured hardware. So this is to make clear that everything I tell you today will not make your digital currency solution 100% secure. But Java card technology and secured hardware can help you to raise the security level significantly. And that's our topic for today. So let's start with the agenda. This webinar will have 3 parts. First, I will give an overview about different types of digital currencies. Then we will look into the various types of secure hardware devices to support digital transactions on digital currencies. And finally, that's the 3rd part, and this also connects to this webinar series. We will have a look into how Java card can support you in your digital currency projects. So let's start with an introduction to the different types of digital currencies. And here, let's have a look at what digital currencies really are. Looking back into the old world, we have conventional money, on the one side cash, and on the other side commercial bank money, effectively your bank deposits that we can move around like consumers using wire transfer from account to account, or in e-commerce using a debit or a credit card. So we call this EMV card payment. That's when you pay with your credit card in the store. But there are also stored value card solutions and playing in certain regions. So in Europe, for example, we had some stored value card solutions in the past with Mondex in France, Chipnik in the Netherlands, or the famous Geldkarte in Germany. That were in the end not very successful, or at least they didn't survive. But in other countries like Japan or Indonesia, they are still used, and many people probably know the Felica technology in Japan that is the basis of a variety of stored value cards. However, this all is not considered as digital currencies in the context of this presentation. As digital currencies, we really mean few new forms, so really new forms of money that have evolved over the last years and that are somehow a digital form of cash. And we can categorize them essentially into three types, which are crypto assets, stable coins, and central bank digital currencies, so CBDC, central bank digital currencies. All these forms of digital currencies I can hold in a digital wallet, and I can use them in various digital scenarios. So let's have a look into these three new forms of money more in detail. I want to say thanks to Dr. Jonas Gross from the Digital Euro Association who structured this for me. So in this first column, you see crypto assets, and crypto assets have currently the biggest market capitalization today with around $1 trillion. And the largest project of crypto assets is the well-known Bitcoin with around half of the market share. Another well-known project where even other products, currency products can be built upon is Ethereum. So what are the use cases of these crypto assets? As the name already imply, it is a new class of assets with sometimes very volatile value. And this value is based on the scarcity of the digital assets. So many people just use it to invest and store value in digital form. But of course, it can also be used as a mean of payment in e-commerce scenarios or in a store or for person-to-person payment. That means I transfer you an amount of Bitcoins like I would give you a 10 euro bill. That's crypto assets. Now let's have a look into a second big category, and probably a very promising category for future applications, and these are stable coins. This category of digital currencies, as it is bound to a conventional currency like the US dollar, is likely to be used more in commercial scenarios in future. Stablecoin platforms like Tether, so the abbreviation is USDT or USD coin, have together a market capitalization of around 125 billion US dollar, which is also not bad. And even there is this latest project in this category from PayPal, a stable coin called PayPal USD, or abbreviation is PYUSD. And such announcements are creating even more traction around this form of digital currencies. So the use cases for stablecoin are not the storage of values mainly, but mainly decentralized finance payment transactions that overcome the limitations of traditional currencies like cross-border payments and digital transfer of money in e-commerce, point of sales, person to person. And a new use case that comes on top of the use cases we already saw with crypto assets, and that's machine-to-machine scenarios. So that's also later you will see that's an important point that you can use it, or really a good use case is this machine-to-machine payment. But also stable coins, as the last point, is used as a hedging instrument. So that means stable coins can be used to reduce risks in an overall cryptocurrency investment due to their price stability, because they are not subject to this say, market volatility as other cryptocurrencies like Bitcoin. And also there are ongoing regulations, like here in Europe, we have this markets in crypto assets, MiCA regulation, that give a useful framework for this type of digital currency. So in all, stablecoins is certainly a form of digital currencies that should be on your radar in future. And then there is the third category of digital currencies we want to have a look on in this presentation, and this is CBDC, or central bank digital currencies. To be more concrete, it is even a special form of CBDC that we mean, namely a retail CBDC used in retail, as opposed to a wholesale CBDC used for interbank purposes. So retail CBDC, as the name implies, are centrally managed, usually by a central bank, and this is not a decentralized currency like Bitcoin. It is issued by a central bank to offer a third form of money available to the general public beside this cash and bank deposits that we had before. And its primary purpose is payment. So for CBDC, it's difficult to speak of market capitalization and use cases, as CBDCs are still in development all over the world. And a major question that needs to be solved still is what advantages such a CBDC has over private sector alternatives, card payment, stable coins, and so on. So only this will really make sure that it is indeed used by the citizens of a country or region. So if they see a sense over other means of payment. And if you want to get an overview about CBDC projects that are in research or in pilot phase, and even some few projects are already launched, Best Overview gives you the CBDC tracker that allows you to track all the projects worldwide and receive more information on its structure, underlying technology, project partners, and use cases. So try this out. You will find it under cbdctracker.org. So having looked at the three types of digital currencies, crypto assets, stable coins, and CBDC, let's have a look at some of the risks that you are facing if you are using digital currencies. Certainly, there are many risks involved when using digital currencies, and here are only shown a few of them. However, using digital currencies with the right devices reduces some of these risks significantly. And there is, for example, the risk of losing your money. Like you can lose your cash effectively with digital currencies. You are your own boss over your money, and there is no third party who can help you to recover your money unless you give your money in the hands of an online crypto exchange provider. So this is also called, so this online crypto exchange provider, this is also called self-custody. So making the user, other way around. If you have the control over your money, that's called self-custody. So making the user really completely responsible for safeguarding their private keys that protect their assets. So you have these crypto exchanges, of course, who tell you they will keep your key safe. They are called crypto custodians, but so many of these custodians messed up and lost people's money that it cost regulators today to look after that. So now everybody's getting back to these basics and managing their own crypto assets in their own wallets, so self-custody instead of custodians. But in this case, it's really essential to protect your cryptographic keys that in turn protect your digital money. So the next risk is double spending. And it is more a risk for central banks when issuing CBDCs. One of the desirable features of a CBDC solution is the ability to perform person-to-person transactions, so P2P transaction in offline mode, similar to a cash payment. In this mode, digital currencies could be locally and securely stored in a dedicated device for long periods of time. They would allow transitive P2P payments so that the funds can be received and be spent offline multiple times before they really require a connectivity to a network for validation. So, and a core risk in this mode, in this offline mode, is double spending, because funds need to be available locally and must be trusted on sender and on recipient devices without relying on the connectivity to an authoritative or to a verification service. So the solution to this problem typically is tamper-resistant hardware and secure software on top of it. And altogether, this constructs a secure and portable platform that you can trust. By the way, coming back to double spending, in the past, various stored value offline payment or those charge cards, they faced a similar risk. Yeah, if you look at Mondex, Geldkarte, Chipknip, they really also already had this this risk of double spending. So it's not something new. So then, of course, there's the risk of cyber fraud because most, not all, but many digital wallets are connected to the internet. But the internet is an entrance gate for attackers and all kind of cyber fraud. So too much trust in a rich execution environment like your laptop or your mobile phone is not a good attitude. And finally, impersonation, practically that's identity theft. So this could be an account takeover due to password-only protection of your money, and ideally you enhance this by a second factor authentication. So you see all in all the variety of different risks that needs to be addressed by a good digital currency wallet. And as I said before, it's definitely not all risks are listed here. So now let's come to the second part of this presentation. I will show you some different types of secured hardware devices to protect digital transactions. And a word in advance to this slide. So my feeling really is that the biggest challenge to adoption of digital currencies in mass markets is this mass market explainability. Yeah, while Bitcoin and other digital currencies have done already a great job in explaining this, how digital currencies work, it's still not understood by the average consumer. So one way to solve this is to introduce devices that are known to the consumer and that imitate payment processes they know, like e-commerce or card payment. So now let's have a first look at typical hardware devices for crypto assets, this first column. And example of assets, we already talked about this, are Bitcoins or Ethereum, but also NFTs or NFTs stand for non-fungible tokens, which is a unique digital asset that represents the ownership of a specific piece of content or media, like an image or a video, audio, or some digital art. And unlike fungible assets like cryptocurrencies, each NFT is one of a kind and you cannot replicate it or exchange it for something else, as it really represents a unique proof of ownership. So NFTs have become very popular among artists, musicians, and digital creators who see them as a way to monetize their work and preserve the authenticity of their digital creations. So You see, crypto assets needs not to be only currency, but could also be a real digital asset. So the devices for crypto assets must handle mainly blockchain technology and decentralized transaction. So you might know that there is also mining part of the game, but mining of assets is not usually what a typical consumer would do. So the devices should be able to handle blockchain technology, should be able to handle decentralized transaction. And for these crypto assets, typically hardware is used for cold storage digital wallets. And I will explain in the next slide what this is exactly. But first have a look at some other forms. So here in this first column, you see USB device, and you also see cards as hardware cold wallets. So stable coins, they are usable in digital wallets for payment as well. So you have the same as with crypto assets, the same devices that can address also stablecoin. But additionally, they are very suitable also for machine-to-machine payment use cases. And this requires, if you want to secure this, an embedded secure element or embedded security in machines that are able to work on the blockchain securely. For example, with smart contracts. So smart contracts, explained quickly, are self-executing digital programs that are designed to automatically enforce the terms of a contract without that there is any need for intermediaries. And finally, devices for CBDC. So for example, for the digital euro, digital dollar, or the digital yuan. These are usually not based on blockchain technology, but on various other digital ledger technologies. You remember that's centralized systems where there is, for example, a central bank standing behind. And as they are central bank driven, wallets are sometimes in smartphones or in traditional payment cards. That's what I mentioned earlier, to imitate a little bit the payment behavior that consumers are used to. So now let's look into those different types of devices. You saw here USB devices, you saw cards, you saw M2M. Let's look into this a little bit more in detail. So USB sticks or companion devices can be used as cold storage digital wallets. But what exactly is cold storage? So cold storage is a way to keep your crypto safe by hiding the secret keys offline, where no one can really mess with them. So you make them inaccessible to hackers, to attackers, and other unauthorized individuals. So this is opposed to hot wallets on the other side. They are connected to the internet and can be vulnerable to attacks from the cyberspace and so on. So really the online connectivity of hot wallets makes them on the one side more convenient, but on the other side less safe to use. And the keys are the essence of your crypto assets. Yeah, we had this before. So without these keys, cryptocurrencies can't flow. Therefore, there is this popular saying, not your keys, not your coins, or not your keys, not your crypto. And in the past years, there were some major security incidents that targeted hot wallet applications and their crypto and NFT assets that were exposed to the internet. So primarily also mobile wallets are vulnerable. Yeah, so mobile wallets are the main targets. And as a result, those cold storage is currently considered as the best way to protect your crypto assets from theft. And hardware wallets typically use encryption, of course, can use biometric verification, can require the user to physically press a button or even enter a PIN code to approve transactions. So this all adds an extra layer of security. And finally, of course, there's always a companion app on your desktop PC, on your laptop, on your mobile that manages your offline coins and speaks to the cold wallet. So here are a few examples of cold wallet devices. And I have to say that this is only a small choice of available cold wallet devices. There are certainly much more, and not all use the same level of security. And also my choice that does not imply that they are using necessarily Java card technology. It is more to show you a choice of real life examples where this use case of cold wallets is demonstrated. So this could be either as USB device, like Ledger or Trezor, or like Elipal. This is a companion device which is using QR code as transmission technology. So this QR code with this Elipal wallet is considered as even as an additional security mechanism, because the device is somehow air gapped from the mobile app. Yeah? There is an air gap between this companion device and your mobile phone. That means this device is not constantly connected to the network. So there is no Bluetooth, no Wi-Fi is not available. And this principle of air gap really now leads me already to the next product category, NFC or contactless cards that are used as cold wallets. So that's the card usage, and a smart card is a major technology on which you can launch a hardware wallet as well. So with a tamper-resistant secure element, and it has the card itself has a smaller profile, so you can store it easier in your physical wallet, in your pocket. And therefore, smart card really finds more users in this hardware wallet market right now. So, and unlike those dongle or USB offerings, smart cards is not using physical wired or USB connection, or cannot run out of power. Yeah, I mean, that's also a big advantage, that a smart card is always working, and it powers itself from a contactless field or from a reader. And well, usually the private keys are generated, encrypted, stored in the secure element on the card, and there is, as said, no connection to the mobile wallet. And so the smart card really leverages. So if you have a smart card that is using contactless or NFC, that are really leveraging this technology, which is much more shorter range than Bluetooth connection or so. So you really have to actively tap your card to your mobile phone if you want to do a transaction. Yeah. So the private keys that are generated on this secure element on the smart card is never leaving the card. It's only residing inside the card. And if you do a signing, a transaction, then you tap the card to the phone. So this NFC in this case is also considered as an air gap. It's a communication technology, but of course it only works if you tap the card to your phone. You have to actively tap the card to your mobile phone. So smart card also can be used for other use cases. That's also an advantage. So you can do FIDO second factor authentication on it. You can do a traditional EMV card payment transaction on it. That's also quite a good advantage of card. So let give me also here some examples for card-based hardware wallets. And also here I have to say that the amount of protection and crypto functionality varies from the different implementations on the different card products. And of course, also here, there are other solutions out there that are not shown on this slide, but just that you get an impression how this looks like. So now going away a little bit from this hardware wallet, let's look at a typical use case of stablecoin, and that would be this M2M use case. And to be honest, I did not find so much examples of this use case, but there is one pilot that is known to me, and it's about a pay-per-use rental model based on blockchains. That's an Austrian tractor manufacturer, Lindner Traktor, and together with a company, Cash and Ledger, they created an automated rental and billing process that is using smart contracts that are stored in the blockchain. So with this process, they could bill according to usage pattern of the tractors, also according to the functionality the user were using, and even the time of the usage of these tractors. And at the same time, they could even gather data for inventory optimization and others. And in this use case, it would be an embedded secure element in such a system that could also additionally do other things, like it could be used to authenticate the machines to each other. But essentially, that would be this M2M use case that could also be secured by hardware. And finally, that's the last example. It's offline CBDC transaction. So why offline, you may say? In our hyper-connected world that we have today, why do I need to do offline a transaction? Well, many countries already rely on digital payment systems instead of cash, which is not yet always a CBDC system, yeah, but it's card payments, it's stored value payments. But we really go into a growing dependency on those systems, and that can affect our ability to pay, yeah, when they became unavailable. So once there is a system outage, cyber attacks, or just a natural disaster, they could become unavailable, and then we cannot pay. So an offline payment transaction is a transaction between two parties which are not connecting directly to a ledger system. And there is a great publication or white paper from the Bank for International Settlements that gives further reasons to have offline CBDC transactions. And I want to quickly go through them. So first thing is resilience. We just had this, and then cash resemblance, like the use case of passing a 10 euro bill to somebody else would resemble this offline transaction in a digital form. Inclusion, so the ability that all of our society can use a currency. Lack of infrastructure, so there are still many parts of the world where connectivity is not there. And privacy, offline, I transfer some money, it has a certain level of privacy, but of course this has to be balanced with regulation like anti-money laundering and know your customer regulations. That comes on top of this. Lower transaction costs, of course, with an offline CBDC transaction, the message does not need to be sent to a central component. And with it comes also performance and scalability. So this offline payments could also be used for micropayment use cases where a machine, so you pay really small amounts. Universal access, so I can get digital cash from from many sources and not only from a central source, but offline. You could have more than one source of where your offline money comes from. Civil contingency, so CBDC payment would still be possible if other means of payment are not, due to conflicts or natural disasters. We had this earlier. And of course, trust. So if your currency works even without network, there's a certain trust factor. And finally, P2P and P2B, so person-to-person and person-to-business payment, where people exchange money between them or between them and a business in the same way as they would exchange cash today. So have a look at this really interesting paper. I put the link into the presentation, and as Clement said, this presentation will be distributed later. So now that's the last part of my presentation. And after all these examples, let's come to why Java Card and how Java Card can support digital currency cryptography. So, and as an intro, we have to have a look at blockchain security, because many, not all, but many digital currencies are based on blockchain security. So blockchain infrastructure itself already provides security. That means due to the centralized nature of blockchain, each transaction is verified and recorded by many participants in the network. So this creates a distributed ledger that is virtually tamper-proof, as any attempts to tamper with the data would immediately be detected and would be rejected by the rest of the network. Additionally, the use of cryptography, cryptographic algorithms enhances security, and therefore the security of the blockchain infrastructure can be called inherent in its design and architecture, so making it really a highly secure technology for storing and transferring digital assets. So the essential point, as already discussed, are the private keys that are defining your identity and interact with the blockchain. So the secure storage of the private keys, this is therefore the essential thing. Now, with a hot wallet, you do a lot of critical functionality on your mobile device or laptop. Yeah, you do transaction signing. You're using your private key to move your money. You are generating your private key on your device. You are storing your private key on your device. You may validate a PIN to access your private key in order to sign and move your money. Maybe also you want to recover a private key from another device, or you just want to use a second factor authentication, which protects against passport scams or phishing. But there are various attacks that can be run on such platforms, and again, the list is here not exhaustive, but there are jailbreak, there are debuggers, there are observation attacks, code tampering, or just cyber fraud. So what you can do is to move the critical functionality into a device that is ideally air-gapped and run it there on a secure element. So typical functions here are the key creation methods like BIP32 or BIP39, the different cryptos you see here, Bitcoin, Ethereum, and so on, and then some elliptic curve-based signature algorithms. And you also have the randoms that you generate, that you use to generate keys. There could also be a device PIN code, or there could be a second factor mechanism for your wallet. So all those critical functions you could move into this separate device that is, as I said, ideally air-gapped and using a hardware secure element. So let me go to the next slide. So how is such a hardware secured wallet usually constructed when it is based on Java card? So we are here in a Java card forum webinar. So this is the architecture if it would be based on a Java card. So on the basis you have on the device side, on the basis you have the security controller with a Java card operating system that runs a Java card virtual machine. And this Java card system features a crypto API that provides this necessary crypto to an application, or in Java card we call this applet, that runs on the virtual machine and provides itself a command set to the crypto wallet app. And so that's the green part. So that the nice thing is that with Java card, what you see here in green, you can create yourself and adapt it to your specific security needs or the level of security your customer expects. And again, you have a custom command set on top of this Java card secure element that interacts with your crypto wallet app, that in turn then of course communicates to a digital currency exchange server in the cloud. And maybe let's go step by step. So what do we do during such a hardware cold wallet transaction and setup? So first of all, we're setting up the hardware wallet. A private key is generated using a cryptographically secure random number generator inside the secure element. Private key is stored securely within the secure element, which is a tamper-resistant chip specifically designed to protect those sensitive information. And then comes a transaction request. So you want to send a transaction, you input the recipient's address and the amount you want to send through the hardware wallet's interface. So you enter this in your crypto wallet app. And then the wallet software creates, still not in the secure element, the software creates an unsigned transaction containing the transaction details, again with the address, the amount to be sent, and some fees that are maybe required. And then the unsigned transaction is sent to the secure element. So you tap your card, or you now at your companion device or your USB device. And ideally, if your hardware wallet now has a display, it also shows the transaction details on the screen. And then you should verify that really the recipient's address and the real amount to be sent and everything is correct. And if everything looks good, you can confirm the transaction on the hardware wallet. And the secure element then uses the stored private key to digitally sign the transaction without exposing it to the mobile phone or the internet. And only the signed transaction is then returned to the wallet software. And then the wallet software broadcasts the signed transaction to the blockchain network, where all the nodes verify the transactions and by checking the digital signature, and then it's put on the blockchain. And once the transaction is verified and included in a block by a miner, it's then considered as complete, and the cryptocurrency is transferred to the recipient's address. So all this happens basically in this architecture. So now let's go a little bit deeper into Java card crypto. And here are the three most common functionalities that you would probably want to be executed in a secure environment. And the first thing is key generation and key derivation. So this can be on the one side non-deterministic. That means a key pair is generated inside the secure element using a secured random number generator. Or it can be deterministic, by receiving a seed from a so-called mnemonic word. And mnemonic words is another form of private key. So when you lose your wallet, the mnemonic word can recover your seed. Then you can recreate your private key of all your coins into a new wallet. If you have this mnemonic word with usually 12 or 25 words that you can remember, that you can write on a paper, keep in your safe, and this is if you want to recover your hardware wallet in case you lose it. But really, the seed has to be kept very, very safe in a physical safe at home. And there is another deterministic method based on master node and child node key derivation, but I don't want to get into this detail so much. And you see there is all kind of cryptography behind this and random number generator. And usually Java card platforms or many Java card platforms already provide such APIs that you can use in your applet on the hardware wallet. For signature and transactions, you then need a selected set of elliptic curves. Most important are the couplet curves. Those couplet curves are the most typical curve that are used, for example, in Bitcoin and Ethereum. But there are also other curves could be of interest, like NIST and Edward curves. And to mention here also this SLIP 10 standard. So with this standard, a root key can be used to generate a sequence of child keys that can create multiple public and private key pairs for different cryptocurrencies and all from the same master key. So this essentially, the standard makes it easier to manage multiple cryptocurrencies and private keys using a single seed, reducing the risk of losing access to your funds. So if you want to implement this, then probably you also have to look into those two other elliptic curves. And finally, for backup and key storage, you can again use key recovery methods based on BIP39 or seed import. But the essential thing is that for all these functions, many Java card platforms offer already the required cryptography. And finally, and that's already my last slide, I want what is really missing now is that I show you one example of a Java card platform that can be used to create a customized secure hardware for your cold wallet or CBDC or stablecoin M2M use case. And such an example is the Sicora ID Java card platform that has extensive options to customize. It's a real open platform. So it means you can program your own code on top of it. Based on Java card language, comes with Eclipse-based development tools and also training and support. And of course, the underlying chip and operating system is security certified, and it is also enabled to provide you a composite certification that also includes your custom applet into a possible certification. So I copied you a link into that slide in case you want to look up more information about this specific Java card platform. And with this, I'm coming to an end of my presentation, and I hope you enjoyed it and found the information useful. And well, now I'm available for your questions if you have one.
So thank you, Timo, for this excellent overview. I think it really gives us a good good overview on digital currencies and how they could be implemented in a Java card environment. I mean, we have this well-established technology. And as I don't see any questions so far in the chat, I have one question for you, Timo. And it's, what impact will quantum computers have on digital currencies? What do you believe?
Well, I mean, definitely cryptocurrencies are using a lot of asymmetric cryptography, which will be impacted by a quantum computer if they come at a certain time. And I think the important thing is here, of course, that the designers of cryptocurrencies have this in mind and kind of also think about how cryptocurrencies could be designs that are also working in a future world where there could be quantum computers that could break those algorithms, because a lot of cryptocurrencies are based on this security of the cryptographic algorithm itself. What JavaCard could do, and what we are already discussing in JavaCard forum, are APIs that make available PQC, so post-quantum cryptography on JavaCard, like Kyber or Dilithium. So that's what we can do from JavaCard side. But yes, there will definitely be an impact also on digital currencies.
Okay, thank you. And then some questions are coming up here. So first one, what license restrictions are there for Secora ID platform? Can our Java applets be open source?
So of course, your Java applets can be open source. Secora ID, like any other Java card platform, there are license terms, but I cannot go into this into detail now in this presentation. But of course, also Secora ID, like any other Java card platform, can run open source Java applets.
Okay. Thank you. Then next question. How does Secora ID compare with SLE78 as a platform?
Yeah, so I mean this, and I go back to this slide here, is very often misunderstood. So there is the chip hardware, that's a security controller. On top of this, there is a Java card operating system. So in the case of Secora ID is the solution with the operating system, and SLE78 would be the chip platform.
Okay, thank you. And then we have, are all necessary operations exposed in public Java card API, or one need also proprietary Infineon packages?
So a lot of, or in all the examples I showed today are available in standardized Java card API. So there are standards available for all those elliptic curves, for this principal cryptographic things that you need for Java card. Of course, every Java card platform usually has also some proprietary APIs, some toolboxes that provide some certain features, and this is product specific. And certainly this is also for Secora ID, but I cannot go into detail here.
Okay, and maybe another one more commercially to Secora ID. Can be Secora ID bought in small quantities?
Oh, here you would have to ask Infineon sales. That is not my topic, and I can only talk about the technology.
And then if one were to use SLE78 without Java card, does Infineon have other OS code and support code for cryptography? I know other Infineon products are moving to Rust. Will SLE78 support Rust soon?
So this question goes a little bit too much into the detail of Infineon. I mean, I have to remember this is a Java Card Forum webinar. I can answer technology questions on Java Card, but here I'm not aware of the roadmap.
Okay, thank you, Timo. And then I think that's it as far as I can see for the Q&A part, or is there any further question from the audience? No? Then thanks a lot, Timo, for this presentation, and thanks to all in the audience for participating in this webinar. I hope that we see and hear each other again in one of the next sessions. And with this, I want to close the session for today. Thank you for joining and have a nice evening wherever you are. Thank you and goodbye.
Thank you. Goodbye.
Thank you. Bye.